Hi everyone, today we want to make a presentation for topic 2.0, which is a differentiation. Assalamualaikum, my name is NURUL binti HASHIM. My matrix number is 08DEP21F1081.
Assalamualaikum, my name is ADILAH binti SHAMIR and my matrix is F1137.
Hi, Assalamualaikum. My name is BAZILAH binti NORDIN and my matrix number is F1083.
My name is IKLIL binti AZHAR and my matrix number is 08DP21F1066.
Let's get it. What is differentiate? In mathematics, the derivative of a function of a real variable measured in the sensitivity to change the function with respect to a change in its argument. Derivative of the fundamental tool of the calculus. Differentiate is means gradient of the tangent to the curve y equal to fx. And we also provide in our slide, they have differentiate rule, which is we have constant rule, power rule, product rule, quotient rule, and chain rule. Next is introduction of stationary point of a curve, which is a stationary point of a function fx is a point where the derivative of fx is equal to 0. These points are called stationary because this point the function is neither increasing nor decreasing graphically. The corresponding to point on the graph of fx where the tangent to the curve is the horizontal line.
Example 1, we have here, we asked how to find the coordinate of stationary point f of x equal to 0 along the curve defined as y equal to x squared minus 4x plus 1. And now we can get started to find the coordinate of a stationary point. We are going to follow a 3-step method, and the first step. Step 1, we need to find the derivative function. So I will just write find dy dx. Now look at the function we have here. We have y equal to x squared minus 4x plus 1. So I will just copy that. That's y equal to x squared minus 4x plus 1. And to differentiate this, we use the well-known power rules, which will look something like this. dy dx equal to 2x minus 4. And of course, the ones that we have here vanish when we differentiate. Okay, that's the end of the step 1. We now have the derivative function. We move on to step 2, and in step 2, we need to solve the following equation. dy dx equal to 0. Remember, at the stationary point, the derivative function equal to 0. Consequently, we need to solve this equation. So in this case, since the derivative is 2x minus 4, we need to solve the following 2x minus 4 equal to 0. So we solve the equation for x, which leads to 2x equal to 4. And finally, that leads to x equal to 4 over 2. In other words, x equal to 2, and that's the end of step 2. And at this stage, we can state the curve has one stationary point and its x coordinate is 2. We now move on to step 3, and in step 3, we need to calculate the y coordinate of the stationary point. To calculate the y coordinate, we need to go back to the function we were initially given. Remember, that was y equal to x squared minus 4x plus 1, and we replace x by the x coordinate of the stationary point. Remember, that was x equal to x, so that will be y equal to 2 squared minus 4 times 2 plus 1. That equals to 2 squared, which is 4 minus 4 times 2, which is 8 plus 1, that's equal to 4 minus 8, which is negative 4 plus 1. Finally, y equal to negative 4 plus 1, that equal to negative 3. And we now have the y coordinate of the stationary point. So we can state that this curve has a stationary point with coordinates to negative 3, and we are done. Now confirm this by looking at this function curve in there. If we plot the curve y equal to x squared minus 4x plus, it would look like this. Looking at this curve, we can see clearly here that this curve indeed has stationary point with coordinate to negative 3. In fact, it's the global minimum point, and at the point we can state that the derivative dy dx must equal to 0. Furthermore, we can also point out that at this stationary point, the tangent to the curve is horizontal. And there we have it. That's how we can find a stationary point. Thank you.
Introduction of rate of change. The rate of change is one of the essential characteristics of a function. A function describes what the relationship is between two quantities. The rate of change tells us how one quantity changes as the other changes. Rates of change are everywhere. One of the more important applications of derivative in a real problem is to calculate the rate of change. Division allows us to find rate of change. For example, it allows us to find the rate of change of area.
So here the example question for the rate of change. The length of a square L is increasing at a rate of 3 cm per second. Calculate the rate of change of the area. of the square at the instant when the length of the square is 20 cm. So that means dl per dt is 3 cm per second. It wants to find dA per dt and the square is 20 cm. So it wants to give us a square. If we want to draw the square, it is better so that we can see more clearly what we want to find. So what this question want is area. Area of a square is L square. L multiplied by L, so that dA dt is 2L. Now we need to find dA per dt. So step 2, we have to modify, meaning near the top there must be dA. dA per dl multiplied by dl per dt. There is a term we have to reverse and there is a term we can use it directly, meaning dA per dl is 2L. dl per dt got 3, all of them are 6L. Calculate the rate of change of the area of the square at the instant when the length of the square is 20 cm. So when L is equal to 20 cm, dA per dt is 6 times 20, means it is equal to 120 cm per second. So that's all from us. Thank you for watching.